Welcome to the Advanced Physics Lab, room 130. Come on in. We have two setups of equipment, one on this bench and the other one on the back bench, so that the students are well separated. And let's start with the first lab, which is the tabletop X-ray diffractometer. The first thing we notice is that this top here is a protective layer. It has some lead in it. That's why the plastic is colored. And you cannot lift it up because you have to move it to the side to open it, right? If it's this way, it's locked. That interlock allows you to put the X-rays on. So the first thing you would do is you would shift to the right, and then we could lift it up. This is the X-ray source. We discussed it in class. If you could see, there's a cylinder back there which is made of copper. The electrons that will be generated from a filament will get accelerated to that anode, and X-rays will come out. The X-rays that come out are going to be diffracted from a crystal. First thing I want you to understand is, as we discussed in class, the crystal rotates an angle theta and the detector will rotate an angle 2 theta. So if I move the detector to 90 degrees, you can see that the crystal will be at an angle of 45 degrees. Let's mount our crystal. Let me show you how to do that. Here is the crystal. We are mounting the lithium fluoride crystal. You can see lithium fluoride right there. These are salt crystals, so you don't want to touch them with your fingers because your sweat on your fingers will start to dissolve the crystal, and then as it dissolves, it will corrode the support holder. So we use tweezers, and we're going to mount the crystal right here in the support like that, and then we close the clamp and we make it snug. So there's the crystal. So again, you can see that when I have the detector at 2 theta, the angle between the crystal face and this line here will be 45 degrees. We keep the X-ray source fixed. The angle between the X-ray and the crystal will be 45 degrees at this point, and the angle between the reflected beam and the detector will be 45 degrees. So remember, you're going to be recording these numbers here, which are twice the angle of incidence and reflection. Here is our detector. It is a Geiger Mueller tube, and in class I showed you how these things work. The X-ray will come in, generate an electron pulse, which then gets detected by the electronics of this controller here. The X-rays are coming through a tiny slit, which is 1 millimeter at the exit of the X-ray source. And here is the 1 millimeter slit that you will be mounting in front of the Geiger tube. We will also use a 3 millimeter slit, and that will be obviously much wider than this one here. So we put that in there. Everything is ready to go. The voltages for our X-ray source, we have two choices, 30 kilovolts and 20 kilovolts. When we do the full spectrum, we'll use the 30 kilovolt voltage for the X-ray tube. Okay, everything is set to go. We can now close the top, and then we slide it to the position where it no longer opens, and then that will allow us to turn on the X-ray source. The first thing we do is we turn the system on. There's a key here which will turn this on. We just turn that on. And then there is a timer here which has an arrow, and it goes up to an hour, right? So I could set it to 55 minutes. And that way, if you forget to turn off the instrument for some reason, it will turn off by itself. So if you're in the middle of an experiment and all of a sudden everything just shuts down, chances are you've been working for longer than an hour and this timer has switched everything off. Don't be alarmed. You could just reset it and start it again. So I press this button. This is the on. We've already got the key, which gives us power. We're going to press the X-ray unit on. And we see the filament. You can see the bright filament back there. Remember in class we discussed that the hot filament will release electrons. We put a positive voltage onto the copper anode and we get X-rays. We know we have X-rays on because the red light is telling us. If it's the white light on, that's just for the filament. The red light is telling us that we are in fact getting X-rays out of our unit. Okay, so how do we detect them? We have a control unit for the Geiger tube, and this is the control unit here. It has an on-off switch in the back, this red button, which I'll just turn on, and then we'll see everything light up. And then we control everything with this display select switch. So right now it's on the counts. We can go up or down on the display select. So if we go display select, it goes to time. Time tells us how long do we want to count at each angle. And we can then, I think 10 seconds is a good time. So we'll just go up to 10 seconds. And that tells us how long this detector will count and register the total counts. The next switch is the rate. We don't need that. That's just telling you counts per second. That's not so important. So we'll skip that and go to the high voltage. Right now it's at 0. This detector, as we discussed in class, has to operate at a high voltage. So we go up on the high voltage. We go up to 500 volts. Okay. And we go to the display select switch. The next one is an alarm point. Don't worry about it. That's only if there's a serious radiation leak or if we're counting too high, and that never happens, so we don't need to worry about that. Then the next one, after we keep this display select, goes to the activity sensor, which will, so when I switch this again, we don't see anything here. It's on activity. That's giving us the volume of the clicks that come out of the detector. So right now we want high volume because we want to be able to hear the counts. So we'll go up. And now you can hear X-rays are being detected. They're being detected. And what you're going to do is you're going to start at the lowest angle, and you can read the angle with the red line right here. So right now, if I go all the way to the lowest angle, that's going to read about 12 degrees. Let's count how many X-rays are coming into our detector. So it's going to count for 10 seconds because this is what we set the counter for. And it read 263 counts. Now, part of the first lab is to recognize that every time you count another 10 seconds, it's not going to be exactly 263. Let's go reset it and start again and wait another 10 seconds. 246. So this count total is going to fluctuate about its mean value, and we don't know the mean value. We would have to take this measurement 50 times or so to find out what the mean value is, but will fluctuate roughly about as the square root of this number. So the square root of 225 is 15. So roughly speaking, this should fluctuate plus or minus 15 about its mean value. So let's just go ahead, run this again. And so one of the things you have to do in the first lab is to pick an angle and do this measurement about 20 times at a fixed angle so that you get to see these fluctuations. So now it's 266. So you do that 20 times and write those down, and then we'll run it into our analysis program, which allows you to get the mean value and the standard deviation. So we'll do this 1 degree at a time. So you move it 1 degree, take another measurement, move it another degree. So now let's go up to say 30 degrees and you'll do a count. You're only going to do one count at each angle. You're not going to do this measurement 20 times. You do it 20 times just to show what's going on. So here at this angle, we have 255 counts, and you record that, right? And then you're going to get to some angles. We know that these magic Bragg angles are where the count totals should go up. So if you remember, we've been sitting at around 200 counts or 220 counts, and now we're getting close to a Bragg angle. The count total is going up. And when you get close to a Bragg angle, then you go at fractions of a degree. You keep going 1 degree until you get close to an angle where the count total is getting large, and then we will go 1/3 of a degree near that angle. You will continue all this to out to approximately 110 degrees, so you can see these magic angles, first and second order. So you'll go from 12 degrees out to about 105 degrees or so. The way we're going to measure a fraction of a degree is we're going to use this vernier feature here. Notice the divisions, there's 6 of them. So from 40 to 41, I've gone 6 of these divisions. So every 2 divisions would be 1/3 of a degree. Okay, so that describes the procedure. At each angle, you just reset this count and then go ahead and redo a measurement. Write it down. Once you get your data written down, you will go to the analysis program that I'll show you in a moment, and then you're done with the first experiment. So let me turn this off. I can just go right back to this timer. The simplest way is just to go set the timer back to 0, and it shuts everything off. We can now open the lid again, got to shift it to the side to open it up. And this is very important. You have to remove the crystal when you're done with the experiment. If it just sits there, and if it's a humid day, then the moisture in the air is dissolving the salt crystal, and that dissolved salt crystal will rust out the stainless steel holder. So it's extremely important when you're done with the experiment that you come back in with your tweezers, loosen up the crystal, and take it out, put it back into the holder, and put a cover onto the holder. So we have different tabletop X-ray units, and they're the same instrument but just slightly different models. And so I thought I would show this one. Again, we open it by sliding the top plastic piece over. Now this one, I've already mounted the crystal, and notice that the screw thread of this one is on the right side, and so that means you want to rotate the crystal this way. So if I'm at 0 degrees, we see the X-ray coming flush with the surface of the crystal into the detector. So with the screw thread is on the right, we rotate this way. If the screw thread is on the left, we rotate this way. This one also has a higher current, so we're going to see higher count totals for the X-rays into our Geiger counter. All right, let's turn the instrument on. And we can hear the X-rays. I've already programmed the counter to have the voltage of 500 volts. The count totals on this one are higher because the current going through the tube is higher and the X-ray intensity is higher. So the background is now 750 counts. You can see that right there. And then as I go to the Bragg angle, you can actually hear the meter kind of screaming counts right now. So if I count, we had 750 counts before, and now we're at 34,000 counts. So you can really see where these magic Bragg angles are. So that was this instrument. We'll now move on to yet another version of this on a different table. Okay, now this is another tabletop unit. It's a little bit older. So we go ahead and lift up the shield the same way. And like I said with the other instrument, here we have the knurled screw on the left side. So we're going to, so when it's at 0 degrees, the X-ray is flush with the surface of the crystal this way, and we're going to move this way for increasing angle, okay? And this one has a separate off-on for the X-rays. The filament will automatically go on as soon as we turn on the timer. So you can see that the filament is on, and we haven't even closed the unit yet. So let's go ahead and do that, and then turn the X-rays on with this button here. So that's the only difference. Now, the other thing that's different is the control unit for the Geiger tube. This is, again, a somewhat older model, but you would turn it on. Here's your off-on switch this way, and the voltage is already set to 400. This one has a continuous change with a dial like this. Let's just put this at, say, 450 volts. And now we don't hear any sound because the sound here is more classic. It's going to come out of an audio speaker. So these are the two outputs to drive the speaker. You can see X-rays are being counted, but you can't hear them. So the way we hear them is to connect these two wires here. This sound is more traditional, the clicking sound that you would hear for a Geiger counter. It sounds kind of cool at the beginning, but then it will get annoying after a while. And when it gets annoying, you can just pull out those wires. But the sound helps tell you where the Bragg angles are. We know here we are at some low angle of 20 degrees 2 theta, so we expect smaller counts. This function switch should be in radioactivity. The counting time on the other units where you can go from 1 second to 10 seconds, but here the counting time is either 1 second or 10 seconds or 100 seconds. So we'll just keep it on 10 seconds. But what we'll do is we'll count for 10 seconds, and if it's on continuous, it'll count and then sit there for a second and then start counting again. So let's watch that. It just read 142 counts, and now it read 103, and you could be writing 103 down and then it'll start reading again for another 10 seconds. If you don't like that, if you would prefer, you can do a single reading, and it will just stop after it reads the single reading and sit at that value. The only problem with the single reading, and because this is an older instrument, is that you would reset it with this switch here, the reset switch, but it doesn't really work very well. Look, I push it in and it doesn't reset. I have to, if I keep doing it up. So it took a while for it to reset and then start again. So if you prefer that method, that's fine. And it keeps the count total and until you can record it, and then you press the reset again. So the reset switch is a little bit finicky, but it works fine. All right, so let's, with the clicking sound, we ought to be able to find the Bragg angles. So you can hear the clicking sound, so you know I'm near a Bragg angle. Instead of 119, I should get a lot more. Okay, once you're close to a Bragg angle, you can now fine tune, as we talked about earlier, and go at 1/3 of a degree, okay? So everything else is the same. And then when you're done with the experiment, you can just go to the timer switch and rotate it to 0, and that shuts off the X-rays and the filament.